So here is a little recap on all the things we've learned thus far about logarithms. So the first thing you must be able to do is solve by making common bases. So examine the problem and try to figure out what base they could both be turned into. These problems can both be turned into a base of 4. The left-hand side already has a 4. And the right-hand side, I know that this is 1 over 4 squared, but if I bring 4 upstairs, that would be a -2. If the bases are the same, then the exponents are the same. I'm going to move the 3x's to the right, add 2, make a 9, x equals 3. Okay? The second thing you must be able to do is graph exponential functions. I'm going to graph a basic y equals e to the x. E to the x is exponential growth. Exponential growth because the base is more than 1. It's 2.7. So the special points would be 0, 1, 1 comma 2.7, and then -1, 1 over e. So here is the basic exponential growth, e to the x. It's a dotted one because that's not the actual graph. Now I was asked to do negative e to the negative x. Out in front, this is a reflection over the x-axis, and a negative here by the x is reflection over the y-axis. Oops, A-X-I-S. So I have to do a double reflection here. If I reflect this down over the x-axis, it's going to go like this. Okay, and then if I reflect over y, it's going to go like this. -1 comma e, and it's going to be like this, asymptotic to the positive x-axis. Okay, how about domain? Whenever you're doing a log, you have to have the of be greater than 0. So x minus 4 is greater than 0. X should be more than 4 for this logarithm to work. It does not matter what the base is. The of has to be greater than 0. Okay, here's another domain. It says x squared minus 25 has to be greater than 0. And this is one of those cases where you have to draw a number line. Okay, and when do you need a number line? If number 1, there's a denominator with an x in it, or number 2, it's x squared or higher. In this case, I'm going to factor in x plus 5, x minus 5, greater than 0. On the number line is plus and minus 5. They're open bubbles because it says greater, and then you're going to test the sections. Another approach to this, when we studied quadratics, was drawing a graph. So if you look at this graphically, the parabola would be opening up, touching at -5 and 5, and it would be going like this. Now -5 and +5 are open bubbles. It wants to be greater, and so we get this piece and this piece. So if you're more of a parabola person, in this case only it's a parabola, or a number line. So the answer is from -infinity to -5, union 5 to infinity. What I love about this chapter is a lot of the rules from the past chapters are being used. So it's perfect review for the final. All right, let's write something in exponent form. So you do a log circle. When you have a log and you want to switch to exponent, you use the log circle. Use the log circle. 1/4 to the power of -3 equals 64. It says write in exponent form, so I will. If I evaluated that, I would get 64. To write in log form, you should start by writing the words log and the equal sign. And you put the little tiny base down low. So the base is 6. And then when I do the log circle, I would go over here to the power of, and it's -2, equals the fraction 1/36. That's in log form. Using the change of base to evaluate, I don't have a log base 8 button on my calculator, so what I will have to do is log of 27 divide by log of 8. I'm going to choose the common log with a base of 10, but you could also choose the natural log with a base of e. Does not matter. The calculator answer will be the same. So log of 27, close the parentheses, divided by log of 8, and the answer is 1.58. 1.58. Okay, and then we did do a lot of solving using the log rules here. So here is an equation I have to solve, and I have to use the log circle. 42 to the power of 1 equals x squared minus x. Oh, a quadratic. I'm going to have to move everything over to one side and try to factor this puppy. If I can't, I'll have to use the quadratic formula. But, oh, I believe it does factor. We have x minus 7 times x plus 6. So the answers are x equals 7 and x equals negative 6. Whenever you're doing a log problem, we should probably make sure that the of is not negative or 0. I think 7 is going to be okay. What about negative 6? Negative 6 squared is 36. Oh, both of them are good. Both of them are good. You check in the original equation. All right, number 9, solve using log rules. The base there is e. I'm just going to write the little e in there. Let's see, I can't do any baby algebra. Maybe what I'll do is take the 4 and bring it down in front as a power. Okay, I think bringing the 4 down is going to make this problem a lot easier. Okay, instead of e to the 28th power, maybe what I'll do now is divide both sides by 4. Okay, because that's just a plain 4 divided by 4, and that makes just a 7 over there. So natural log of 6x equals a 7. And now do the log circle. E to the power of 7 equals 6x. Okay, I'm trying to solve for x, so the only thing left to do is divide both sides by 6. So x is e to the 7th divided by a 6. Okay, we'll just leave it like that. It's exact. If you're curious about the decimals, you could type it in, but that's the perfect answer. Number 10, solve using log rules. If you have a problem where there's a log on the left and there's a log on the right, and the base is of 6 and the base is of 6, you can just isolate and look at the ofs. If logs are equal, then ofs are equal. X plus 8 equals 2x plus 3. And now it's just a linear equation to solve. X equals 5. Let's make sure this is okay. If I take 5 and I plug it in, that of is positive, and that of is, yes, positive. Both good. Number 11, okay, similar to what we did today in class, there are 3 things. So I can't just set the ofs equal. Okay, there's 1, 2, 3 things. There's a lot of logs. Maybe what we should do is combine both of those logs into just one log of a base 3. So you're going to have 1 log. We still have equals 4. And the ofs are going to get multiplied. X squared minus 24x. Make sure you use parentheses so all of that stuff gets in the log, in the of. And when you get stuck in log form, you go ahead and do a log circle. 3 to the power of 4 is 81 equals x squared minus 24x. 0 equals x squared minus 24x plus 81. And now we're going to have 0 equals x and x. Let's see, 27 times 3. And I'm going to make the 27 negative, positive. So x is equal to 27 and x is equal to negative 3. Let's make sure both of these are okay. 27 is okay in both of those ofs. -3, ooh, not so much. -3 is not going to work. That's extraneous. The only answer you'd put on the answer line would be 27. Okay. And the last one here says solve using log rules. So I noticed that there are 3 things again. And what are we going to have to do? I can't set the ofs equal because of the 3 things. I think I want to get all the logs onto one side. I'm going to put all the logs, let's put this log on the other side, log base 6 of x minus 5 plus log base 6 of x equals 2. All right, now there's too many logs. I'm going to combine 2 logs into one log. Log base 6 of x squared minus 5x equals 2. When you get stuck in a log, you're going to go ahead and use a log circle. 6 to the power of 2 is 36 equals x squared minus 5x. Quadratic needs everything moved over to one side. Minus 36, and I'm going to try to factor this. So 0 equals, let's see, 9 times 4 minus 9, positive 4. So x equals 9 and x equals -4. Are both of those answers okay, or is one of them extraneous? 9 will definitely work. Oh, but -4 right here is not going to work. So -4 is extraneous and 9 works. What I really want you guys to do is spend a lot of time now, and on the next couple of pages, we've got 3 pages here of multiple choice questions. It's a practice take-home quiz. I need to see all of your work in the packet. Make sure you try all these problems and circle the one correct answer. Pretend like this is a final. Okay, good luck, and I can't wait to see your work. Okay, let's review our log rules to make sure you know all of them, and then we're going to do some practice. The first rule, log base A, any base when the of is a 1. That rule says it's going to equal 0. What if it's log base A of A? That answer is going to be 1. You could do a log circle to check to see if that's right. What if the base is A and the of is A? What does this rule say? Then you get the power R. What if the base is A and then the power has a log and that base is A and the bases are both A? Then you just get M. Okay, these are very popular rules here for when you're solving. If you have a log and the ofs are being multiplied, you can separate this into 2 logs. What are the bases for both of them going to be? That's right, A, log base A, log base A. And you're going to take the ofs and you're going to separate them. This is going to be a log base A of M, log base A of N, and what do you do to the 2 of them? You're going to add them. If the ofs are being divided, you can go ahead and separate log base A of M. That one goes on top, that one goes first. And then you're going to subtract log base A of N. If you have log base A of M to a power, that power can go where? Bring it down in front. The base and the of are different, so we can only bring that down, make our coefficient R times log base A of an M. And rule number 8, if a log equals to a log and the base is equal to the base, then you can say that the of on the left equals the of on the right. Okay, and so you're just isolating the ofs. You're not dividing by log or anything. You're just saying that the ofs must be equal. All right, we're going to use these rules to do some solving and practice and get good at this. The first thing I notice here is I have 2 logs. So I'm thinking about using rule number 8, where a log equals a log, except there's a 2 there. So I can't isolate the ofs. These are not log equal log because there's a 2. Where can I put that 2? If I divide by it, then I'm making a fraction over here, and that's not getting any better. But if I use rule number 7 here, I can take that coefficient and put it up as a power. So let's go ahead and do that. Log base 5, and I'll bring it up here, and now it's x squared. it becomes a power on the of. If you want to use parentheses, you can do that. It belongs to x. Equals log base 5 of a 9. Okay, now I have a log equaling a log. When you have two logs that are equal, you don't do a log circle. Okay, if you have two logs that are equal and the bases are equal, then you're going to isolate the ofs. So what we'll do here is we're going to say x squared equals 9. And I'm going to go ahead and square root it. And so my answer is plus and minus 3. X is plus and minus 3, so we got our two answers. Oh, wait a minute. We have to check to make sure these are going to work. So what we'll do is we're going to plug them into the original equation. That's just a 9, but here, the original one said log of x. Don't look at this one, not squared. The original problem was log of x. So we can't use the negative one. So we're going to cross that off and say x equals 3 is the only solution. Make sure you check your answers. You can't take log of a negative. If the original problem said squared, that would be okay. But the original problem didn't have that. I made that. All right, let's do another one. Wow, this example has a lot of logs. When there's logs all over the place, it might be a good idea to combine them. So let's go ahead and put these two logs here together. Since they're both base 5, you can combine two logs to make one log with base 5. Now, what am I going to do to those ofs? Since the logs are being added, you're not going to add the ofs. We're going to use rule number 5 that says multiply the ofs. Maybe what I'll do is go ahead and multiply them right away. X squared plus 8x plus 12. Let's finish the equation. Equals to 1. Now this would not be a good time to say this stuff equals 1. You can't just make a log disappear. And there's not logs on both sides. When there's not logs on both sides, you can't just take this stuff out of the of. So how are we going to get x out of the log? Use a log circle. Use a log circle. So let's just put a note here. Log circle when only one side has a log. Okay, use a log circle. Or here I go. 5 to the power of 1 is 5 equals x squared plus 8x plus 12. I'll move everything over to one side, and that gives me minus 5 plus a 7. And I'm really hoping this one factors. Factors up. Oh, I think it does factor. X and x make x squared. And how do you make a 7? That's going to be plus 7 plus 1. Okay, so our two answers are negative 7 and negative 1. Are both of those going to work? Wait, just because they're negative, don't just cross them off. We have to put them into the original problem. Is negative 7 going to work here? Well, that's going to make a negative of. Okay, that one is extraneous. I'll just cross it off and write extraneous. Is negative 1 going to be okay? Negative 1 has to get plugged in. Is this of going to be okay? That's going to be log of a 5. That's okay. And negative 1 here, that makes this of positive 1. Okay, that one's definitely going to work. Okay, don't just cross off the negative answers. You have to see if it's going to go in okay to the equation. Okay, let's do another one. Wow, there's a lot of natural logs here. So I think what I'll do is combine these two. Can you combine two natural logs? Absolutely. I'll make one natural log. And what am I going to do to those ofs when it's being added? Multiply them? Okay, so that makes x squared minus 4x. All right, what do I have on the right? I have another natural log. Okay, so we have two natural logs here. So what I'll do, let's see, is this a good time for a log circle? No, because you have two logs. The same kind of log, and they're equal, and the bases are equal. This would be a good time to say that the of on the left equals the of on the right. That would be a good time to say that the ofs are equal. All right, let's go ahead and solve this quadratic. If I minus x, that's going to make negative 5x. Minus 6 equals 0. Does this one factor? Ooh, I think it does. X and x, don't forget your 0. The way that you make a negative 6 would be negative 6 positive 1. So I got two answers. I got a 6 and a negative 1. Are both of those going to work? Does 6 make any of these ofs negative? Oh, 6 is good. How about negative 1? The original problem had log of just a regular x. That is not going to work. Sometimes the positive ones get crossed off, sometimes the negative ones, sometimes both, sometimes none. You just have to check every problem with the original logs. Okay, so we solved that one. Let's do some more solving. We're going to algebraically solve for x. Now, these are not log equations, so we don't need to be careful about checking the answers to see if they're extraneous. There's no logs here. This is an exponent. But x is in the power. So how do I get x out of a power? You can't divide by it. Oh, I know. Switch to log form. What's the base going to be? The base of the log is the same as the base here, 2. Let's do a little log circle. 2 to the power of x equals 5. Well, there you go. You've solved this. If you do a quick log circle, you're going to see that that checks. This is exact. Some people are curious and they type this in their calculator to see what the decimals will be. You'll have to do change of base, of course, but then you'll have to chop off part of the answer. This is exact. So we'll leave it like that. X equals. To solve for x means get x alone. That's what it means, get x alone. Since we got it alone, we've solved it. Okay, let's get x alone over here. Is there anything I can do before I start thinking about logs? Well, yeah, you could divide by 8. So you try to do just basic algebra, some little baby math as much as you can until you get stuck. Okay, so we have the fraction 5/8. Any more baby algebra? No. X is stuck in the exponent. It's a good time now to switch to log. What's the base going to be? 3. What's the of going to be? 5/8 equals to x. You've just solved the equation. Now you don't have to worry about is it extraneous or not because this original problem was an exponent. Okay, so that's a review of some solving. We're going to evaluate this log here for a couple of values. Okay, evaluate means plug in the number and calculate and find the value. Evaluate means find the value. Okay, let's find the value. The first input is going to be 1. Okay, so if I plug in a 1, log base 8 of 1. Oh, that looks like a rule. Go back and look at your rules, particularly rule number 2, and tell me what log any base of a 1 is going to make. That's right, it's going to make 0. So let's see, that makes a point, doesn't it? That makes the point 1, 0. All right, now they want us to plug in an 8. So now I'm going to do log y equals base 8 of 8. Hey, when the base is the same as the of, what does that come out to be? Just a 1. So now we found the point 8, 1. All right, here are the two values. We found some points. What this example was trying to teach you was a couple of things. Okay? When you have a log equation here, there's two numbers I want you to plug in. Always plug in number 1. A number same as the base. Okay, and the second number I want you to plug in is 1. Plug in 1. Okay, that's going to help you with this next example here. We have to find the x-intercept and another easy point. An x-intercept is when you have the y value as 0. How am I going to make a 0? If you plug in 1, you'll get a 0. Do you need to see that? Log base 7 of 1, that makes a 0. Always plug in 1. The other number I want you to plug in is the same as the base. I want you to plug in the number 7. What's log base 7 of 7? Well, that just makes 1. There we go. We found 2 points. This is preparing you for graphing logs. Well, let's do it again. What number do I always want you to plug in? 1. What's natural log of 1? Well, that's just a 0. And then the other number I want you to plug in is same as the base, but I don't see a base. Hey, what's the natural log base number? E. Natural log base E of E is going to make 1. For people that want to see the work here, natural log of 1 makes a 0 because that's rule number 1. And then natural log base E of E using rule number 2 makes a 1. Okay, we'll do it one more time. There's 2 numbers I want you to plug in. The first one is 1, and the second one is, that's right, 1/4, same as the base. What's natural log of 1 always going to make? 0. Log base 1/4 of a 4th makes 1. Okay. There's some rules here, and I want you to study these rules. Some of these are true and some of them are false. So carefully look back at your notes and decide which ones are trying to trick you, which ones are true. Some of these are common mistakes. I want you to bring all your true-false answers with you to class tomorrow. And on this next page are some problems for you to try. So this is where the video is going to end. You are going to continue trying all these, and I want you to bring these answers, the solutions to these log equations, with you tomorrow to class. The video is ending, but your notes must be finished. Good luck!